Hello, y'all. This is your Unit 5 note card. So you should have a Unit 5 note card. I believe they are purple this unit on our trip around the rainbow of your note cards. Oh, what did I just do? So go ahead and throw your name on here. And remember that this is what you get to use on your test. So the very first thing, this doesn't apply to just one section. This applies to every section. All answers for this entire test should be in standard form. Highest to lowest exponent, constants at the end. 5.1, we combined like terms, so we added together things that had the same variable and the same exponent, and then we classified based off of the degree and the number of terms they each had. So degree is our highest exponent. So our degrees, if we have a degree of 1, that was linear. Degree of 2 was quadratic. Degree of 3 was cubic. And a degree of 4 was quartic. So get those down. Then we also classified based off of the number of terms that each polynomial had. So if a polynomial only has one term, that is a monomial. If a polynomial has two terms, that is a binomial. If a polynomial has three terms, that is a trinomial. And then once we get to 4 or more terms, so 4 plus terms, we're going to call that a polynomial. And that just means many terms. So once we get there, everything's a polynomial. Okay. And then like I said, like terms have the same variable and the same exponent. So we are able to add all of our x's together. We're able to add all of our x squareds together. We're able to add all of our x to the fourths together. Things like that. Okay. Speaking of adding and subtracting, 5.2, we added and subtracted polynomials. When we add and subtract polynomials, we combine like terms by adding together their coefficients, and we do not yet change any exponents. You can do that when multiplying. When adding and subtracting, you're just adding together like things. When adding, just add them all together. Don't worry about changing any positives and negatives. When subtracting, what we did was we remembered to distribute this negative to our entire second polynomial, and then we can just add. So if I'm distributing that, negative 1 times negative 7x cubed is negative 7x cubed. I misspoke, sorry. Negative 1 times positive 7x cubed is now negative 7x cubed. Negative 1 times 8x squared is now negative 8x squared. And negative 1 times negative 3x is now plus 3x. So now that we have that done, we can combine like terms. So we can combine together, or we start with our highest exponent. So highest exponent I see is negative 7x cubed, and there's actually nothing we can combine there. So that's just going to go first. Then we can combine, so I use 3 lines there, our 8x squared and our negative 8x squared, and those actually cancel out in this example. So 8 minus 8 cancels out. We can combine our 3x and our 3x to be 6x. And then we can have our negative 5, can just go at the end. So this right here would be our final answer. Okay, so that was adding and subtracting. From there, 5.3 and 5.4, we move to multiplying. 5.3, we were just multiplying a monomial, so we just distribute that. And when we distribute, we multiply the coefficients and we add the exponents. With 5.4, we are multiplying either a binomial by a binomial or a binomial by a trinomial. So we are going to take this binomial, this x plus 1, multiply it by a trinomial, 3x squared minus 2x and 5. Let's go to multiply those out. 3x squared times x is going to give me 3x to the third. Add in my imaginary 1 there. Oh, I forgot this little box over here, my invisible numbers. X by itself is 1x to the first. Negative x by itself is negative 1x to the first. That's why I was adding in here is 1x to the first. Okay, back to our problem. Add in my imaginary 1 here. Top middle box, 1 times negative 2 is negative 2. Add my exponents, I get x squared. top right box, 5 times 1x to the first becomes 5x to the first. Bottom left hand, we're just multiplying everything by 1. So 3x squared times 1, still 3x squared. Negative 2x times 1, still negative 2x, the first. And 5 times 1, still 5. Okay, once we get things multiplied, we can combine like terms and put things in standard form. So 3x cubed is my highest exponent. These two guys can combine together to be 1x squared, because 3 minus 2 is 1. These two guys can combine together. Negative 2x plus 5x is 3x to the first. And then we still have our plus 5 there at the end. Okay, got one more section for the front side of the note card, which was 5.5, greatest common factor. On 5.5, we identify the greatest common factor, and then we divide it out. We factor it out. When we do that, we subdivide our coefficients and we subtract our exponents. So that's the exact opposite of what you just did when multiplying. So we've got 3x to the fourth minus 9x squared plus 12x. There's an imaginary exponent of 1 here. We can divide 3, 9, and 12 all by 3. And then we've got x to the fourth, x squared, and x to the first. You're always going to be able to take however many x's that last term has. So we'll be able to take out an x to the first here. So 3x to the first will be our GCF. Let's go ahead and divide that out. So 3x to the fourth divided by 3x to the first. 3 divided by 3 is 1. Then we subtract our exponents. 4 minus 1 is 3. Negative 9x squared divided by 3x to the first. Negative 9 divided by 3 is negative 3. Subtract our exponent. 2 minus 1 is just 1. And then 12x to the first divided by 3x to the first. 12 divided by 3 is 4. And subtracting our exponents. 1 minus 1 is none. Let me scoot over that parentheses. You stop writing it early. There you go. Okay. This video will be posted on the agenda, so if I've gone too fast anywhere, you can always go back and catch something that you've missed and rewatch it. Okay, flip into the back of the note card. We are almost done. So back side of the note card, we've got 5.6 and 9 cut lumped together, 5.7, and one example of 5.8. So we're going to start with this 5.7. 5.7 was difference of squares. This was our easy peasy one that we saved for last because of that snow day. So for difference of squares, we are looking at a difference between subtraction of two perfect squares. So we've got 4x squared and 81, and we are subtracting them. 4x squared is 2x times 2x. That would be my a value here. 81 is 9 times 9, so that would be my b value. So my factored form here is going to be this a plus b times a minus b. So that'll be 2x plus 9 times 2x minus 9. Okay. Our next one section we had was 5.8, which was factoring by grouping. We use factoring by grouping when there are 4 terms. We start by factoring the GCF out of the first 2 terms. Then we factor the GCF out of the last 2 terms. And we write in factored form that we're going to have 2 sets of parentheses that match each other exactly. And then our first GCF plus our second GCF will be our second set of parentheses. So this one, looking at our first group, out of 2x cubed and 4x squared, I can divide a 2x squared out of both those. So I'm going to write down my GCF for my first 2 is 2x squared. So 2x cubed divided by 2x squared. 2 divided by 2 is 1, and then x cubed to take out the x squared, leaves behind just an x. And then negative 4x squared divided by 2x squared. Negative 4 divided by 2 is negative 2. Close those parentheses because the x squared factors out completely. Out of negative x plus 2, there's nothing I can divide both of those by, but because they are currently a negative x and a positive 2, and I want them to be a positive x and a negative 2, I'm going to divide out a negative 1. So I'm going to divide a negative 1 out. And that happens anytime our third term is negative, you're going to want to pull out a negative. So negative x divided by negative 1 is positive x. 2 divided by negative 1 is negative 2. So I've got x minus 2 and x minus 2. Those guys match and make the first part of my answer. And the second part of my answer is 2x squared minus 1. 2x squared minus 1. There you go. That is an example of factoring by grouping. Okay, excuse me. Very last section, 5.6 and 5.9. So we did not include an example of 5.6 because we literally couldn't fit it on here. But for 5.6, you are always... Oh, just kidding. I did make it fit. Never mind. I misspoke. We included an example of both 5.6 and 5.9 here. So for 5.6, right here, you are finding two numbers that multiply to the C value and add to the middle value. So multiply to the last, add to the middle. So we are trying to find two numbers that multiply to 12, and they need to add to negative 8. So numbers that multiply to 12 are 1 and 12, 2 and 6, 3 and 4. And then if I go look at our table up here, if I need to add to a negative and multiply to a positive, that is going to be this third row here. I want to pick two numbers that are both negative. So I'm going to make all of these numbers negative. And now the ones of these that add together to negative 8 are negative 2 and negative 6. So my final answer here would be x minus 2 times x minus 6. Okay, now moving on to our 5.9 problem. I'm sorry, I forgot I put both of these on here. So for 5.9, we need to find two numbers that multiply to AC and add to B. Then we split them up using that middle number, or split up the middle term using those numbers, and we factor by grouping, just like we just did in 5.8. So I'm going to come use my table again and determine what I am trying to multiply to. So I'm trying to multiply to AC here, which is 5 times negative 3. So that is negative 15 is what I'm trying to multiply to. I'm trying to add to negative 2. So I'm going to come use my magic X up in this empty space up here. I'm trying to multiply to negative 15, trying to add to negative 2. Numbers that multiply to 15 and are 2 apart are 3 and 5. And then if I go use my table, since I'm trying to add to be negative and multiply to be negative, I'm looking at that second row there. I want my bigger one to be negative. So I want positive 3x and negative 5x. So splitting this middle term up, I've got 5x squared. Now I've got positive 3x, I've got negative 5x, and then I still have my minus 3 here. So that's where those come from. It's just me splitting up my middle term. I'm uncombining like terms in the middle there. Okay, so now, factoring by grouping, out of 5x squared and 3x, I can pull out just an x. So that's going to leave behind 5x plus 3. And out of negative 5x minus 3, I can pull out just a negative 1. So it's going to be negative 5x divided by negative 1. It's going to be positive 5x. Negative 3 divided by negative 1 is going to be positive 3. Looky here, these two guys match. So 5x plus 3. And the other piece of my answer is this x and this minus 1. X minus 1. Okay, there you go. Again, if you have questions, if you need to go back and watch another section, this is all posted on the agenda as well. Thank you very much.